Good morning, all. Today we discuss the motion in polar coordinates. In the previous class, we have discussed how to represent position vector using plane polar coordinates and also the relations connecting the unit vectors in polar coordinate and in the Cartesian coordinates. Now we're going to analyze how the velocity and acceleration can be expressed using plane polar coordinates. First of all, we know that the velocity in the Cartesian coordinate can be expressed as v is equal to d by dt of xi plus yj. How it is obtained? That is, we know that in Cartesian coordinate system, v is equal to dr divided by dt. Okay, and we know that the r vector, the relation connecting the position vector in the polar coordinate and Cartesian coordinate can be written as r is equal to xi plus yj. I have substituted xi plus yj here for the r vector. Then it can be expressed as it is d by dt of x and I cap plus dy by dt j cap. Okay, here there are two quantities x and I cap, here also y and j cap, but we only differentiate x with respect to time because we know that the unit vector I dash is constant, its direction and magnitude also constant, so we can treat it as constant. Then dx divided by dt I plus dy by dt j, or it can also be written as, it is a new notation, x dot. In our physics, x dot denotes d by dt of x then x dot I plus y dot j. Y dot means dy by dt. Okay. Now in polar coordinates, we have v can be expressed as in the same way. V is equal to, what is the expression of v? Here, look at here. V is equal to, here also v is equal to dr divided by dt. But in polar coordinate, r vector is equal to modulus r into unit vector r, isn't it? So we write velocity v is equal to d by dt of r cap. Here, this r in italics, it is the magnitude of vector and r cap is the position. But an important point to be remembered here is r cap is not a constant vector. We know that the direction of radius vector and the angle also changes, or the directions of theta cap and r cap changes throughout the motion. Okay, then the two quantities, small the r, italics r, and the unit vector also changes. So here we must differentiate these using product rule. Okay, then we can write it as, it is dr divided by dt r cap plus r dr cap divided by dt. So there is two terms. First one is dr by dt r cap, and the second term is r dr dr cap by dt. Look at the first term. Here it is the unit vector in the direction of r. So there is a radial component. So the velocity has a radial component. Then velocity has a radial component. Okay, and there is another component. It is not, it is in the direction of dr by dt. So it is not in the direction of r. We know that in the plane polar coordinate there are two directions. First one is the direction of r, and the second is the direction of theta, tangential component. Okay, so we have to evaluate dr divided by dt. We can find d by dt of r cap using different method. In our textbook, three method mentioned. Here I explain one of them. We have to find d by dt of r cap. Okay. So we take the relations connecting polar coordinate and Cartesian coordinate. In the previous lecture, we find a relations connecting r cap with I cap and j cap. Can you remember it? R cap is equal to what? R cap is equal to cos theta I cap plus sin theta j cap. Okay. R cap is equal to I write here in the position of r cap. I write the expression of r cap in terms of Cartesian coordinate system, that is cos theta I cap plus sin theta j cap. Then differentiate this quantity, that is d by dt of cos theta I cap plus d by dt of sin theta j cap. We know that I cap and j cap is constant. So we have to differentiate cos theta with respect to time. Okay. What is the mathematical process? First, we have to find the derivative of cos theta with respect to theta, and we have to multiply the quantity with d theta by dt. Okay. So d by dt of cos theta I take I outside, then I write it is d by dt of cos theta. Similarly, from the second term, j cap d by dt of sin theta. Then the rule is d by dt of, I write here to find d by dt of cos theta. Here theta is a quantity that depends, that varying in time. Okay. So as here the variable is theta, here the variable is time, we can change it as d by d theta of cos theta into d theta divided by dt plus in the second term we write d by d theta of sin theta into d theta divided by dt. Look at here, d by dt is written as d by d theta into d theta by dt. So both are equivalent because this d theta and this d theta may cancel. Okay, only d by dt remains. Okay, so what is result of this quantity? Okay, check it. D by d theta of cos theta, the differential of cos theta with respect to theta is, it is minus sin theta d theta by dt. Okay, in physics we can write it as theta dot. Dx by dt is written as x dot, dy by dt is written as y dot. So d theta by dt can be written as theta dot. So plus j cap d by d theta of sin theta, that is equal to cos theta into theta dot. Here theta dot is common in both terms. So I write theta dot, then I write in brackets minus sin theta I cap plus cos theta j cap. Is the bracketed term is familiar to you? Minus sin theta I cap plus cos theta j cap. What is the quantity? Okay, it is theta cap. So we can write it as theta dot theta cap. So dr cap by dt is theta dot theta cap. So the second term is in the direction, the velocity component in the direction of theta cap. So it is the tangential component of velocity. In the previous expression, there is a multiplication with r. So the final expression for velocity can be written as velocity v is equal to r dot r cap plus r theta dot theta cap. It is an important expression. Okay, it is an important expression. It is the expression of velocity in polar coordinate. So consider two special cases. Here the velocity has two components. First is radial component and the second is tangential component. And Now we consider two special cases where only one component varies at time. Only one component varies. As first case, theta can be taken as a constant and the radial component varies. And in the second case, r is taken as constant and theta component varies. So we first take the first, that is theta is constant and r is varying. So the graph must be like this because it is in the velocity is radial, because when theta is a constant, theta dot must be 0. Okay. So we have a one-dimensional. So we have a one-dimensional motion in a fixed radial direction. Okay. In this case, in the first case, there is one-dimensional motion, one-dimensional motion. In which direction? In a fixed radial direction. Okay. Then consider the second case. In the second case, first case we what we consider? In the first case, we consider theta equal to a constant and r varies. So in the second case, look at here, r equal to a constant and theta varies. As r is constant, then r dot must be equal to r dot must be equal to 0. So in this only v is equal to r theta dot theta cap. Then what is special about this motion? Look at the figure. The motion lies on the arc of a circle. We know that r is constant. As the radius is constant, the motion must be taken place in the arc of a circle. Okay. Both in the two cases, in the first case, we take theta as constant, and in the second case, r as constant. Okay. For general case, both r and theta change in time. Okay. Next, we have to discuss the acceleration in polar coordinate. Before going to that, we go to evaluate the d by dt of theta cap. Here we find out d by dt of r cap. It is obtained as, we have find out d by dt of r cap is equal to theta dot theta cap. Now we going to evaluate d by dt of theta cap. We have theta cap is equal to minus sine theta I cap plus cos theta j cap. Okay, so here also I and j are constant, then take it outside. Here there is a minus sign, put it here, then minus I cap d by dt of sine theta plus j cap d by dt of cos theta. Okay, as in the previous case, we have evaluated d by dt of sine theta and d by dt of cos theta. Okay, then we know that d by dt of sine theta is equal to what? D by dt of sine theta is equal to cos theta theta dot. Then it is equal to cos theta theta dot plus j cap. D by dt of cos theta is equal to what? D by dt of cos theta is equal to minus sine theta theta dot. It is equal to minus sine theta theta dot. Here minus theta dot. Here also a minus and theta dot. Then I take minus theta dot outside, then in brackets cos theta I plus sine theta j. Cos theta I plus sine theta j is what? It is r cap, then minus theta dot r cap. So d by dt of theta cap is equal to minus theta dot r cap. It is two important equations. D by dt of r cap is equal to theta dot theta cap, and d by dt of theta cap is equal to minus theta dot r cap. Okay, now we going to discuss about acceleration. Acceleration in polar coordinates. First we consider acceleration in Cartesian coordinate. Okay, we know that in acceleration is written as a. Okay, then a is equal to d by dt of v. A is equal to d by dt of v. Okay, if v is equal to in Cartesian coordinate, v is equal to what? In Cartesian coordinate system, v is equal to x dot I plus y dot j. Okay, then it must be equal to d by dt of x dot. What is x dot? d by dt of x I cap plus d by dt of y dot j cap. Using this dot notation, we can written d by dt of x dot, then x double dot I cap plus y double dot j cap. X double dot simply means d square x divided by dt square, and y double dot is equal to d square y by dt square. It is second order differentials. Okay, so in polar coordinate, a can be written as d by dt of v, that is equal to d by dt of in terms of velocity component, in terms of polar coordinate, velocity can be written as r cap plus r, here no, here there is a dot, r dot r cap r theta dot theta cap. Okay, then we have to evaluate this quantity. First one, d by dt of r dot r cap plus d by dt of r theta dot theta cap. So here r dot and r cap both are timely variable, so we have to use product rule here. Then r dot dr by dt, first quantity, plus r cap d by dt of r dot. We can write it as r double dot, isn't it? It is d by dt of r dot is equal to r double dot plus, here the three quantities r theta dot theta cap, all of them dependent on t. So here also we use product rule, taking two quantities constant and change the third. So first I write r theta dot d by dt of theta cap plus r theta cap theta double dot d by dt of theta dot, okay, plus theta dot here, though there is no other, plus the term the second and theta dot theta cap kept constant and d by dt of r, it is r dot. Here we substitute, we know that d by dt of r cap, d by dt of r cap is equal to what? D by dt of r cap is equal to theta dot theta cap, okay, then r dot theta dot theta cap plus r double dot r cap plus d by dt of theta cap is equal to minus theta dot r cap, okay, then here there is a minus r theta dot square r cap, r theta dot square r cap plus r theta double dot theta cap plus r dot theta dot theta cap. Collecting the radial components and theta components separately, there are two radial components, so r double dot minus r theta dot square into r cap plus there is three tangential component, but the last and first are same, so we can add it, then combining into 2, then the first component r theta double dot plus 2r dot theta dot theta cap, so it is the acceleration. So when we looking at the expression for the acceleration, we know that there are additional components for the accelerations. Here the term r double dot r cap, it is the linear acceleration in the radial direction due to the change in radial speed. And similarly, the term r theta dot r theta double dot r theta double dot theta cap, that is the linear acceleration in the tangential direction due to the change in magnitude of the angular velocity. Okay, so there are some other terms. First one, minus r theta dot square r cap, and another 2 r dot theta cap. So I mention some terms. That is, first one, centripetal acceleration or the centripetal force, and next, Coriolis acceleration or Coriolis force. Is it familiar to you? The more details about the centripetal acceleration and Coriolis acceleration will be discussed in our syllabus in details. So this mathematics, this derivation will be helpful when understanding the rotational motion in our second chapter. Okay, so I conclude our session here. And I will give you some worked out problems from the session. That is, to find out the velocity in polar coordinate in some cases. So please go through such examples and work out it. After that, I will give some homework problems. Okay, thank you.